This video is a review of simplifying mainly exponent rules. Before we dive into the exponent rules, we'll start with combining like terms. So if you look over in the right side under the explanation box, we're going to add the coefficients, which are numbers in front of the variables, of the like terms. Like terms are same variables raised to the same power. So for example, 3x squared y and 4x squared y are like terms. So these two highlighted in yellow are like terms. And then 4x and 5x squared are not like terms because they are not the same variable raised to the same exponent. One is an x and one is an x squared. That does not match. Looking at number 1, all of those terms are plain x's, so they're all like terms. So we just want to add up all those coefficients. Keep in mind if you don't see a number in front of a variable, there's a 1 there. So that third term, the negative x, is a negative 1x. So 2 plus 5 is 7, 7 minus 1 is 6, 6 plus 8 is 14. And when you combine like terms, the variable just stays the same. On number 2, looks like we have two different sets of like terms. I see a 3x that matches with a negative 7x, and then I see a 6x squared that matches with a 2x squared. 6x squared plus 2x squared is 8x squared. 3x plus negative 7x is 4x. I put the x squared term in the front because mathematicians usually like to write their answer in descending order of the variable, which is a fancy way of saying put the largest exponent first and then the next largest and so on and so forth. Looking at my answer, I don't know why I put a plus 4x. That should be a minus 4x because 3 minus 7 is negative 4x. Why don't you pause the video and try 3 and 4? All right, now that you've tried 3 and 4, on number 3, 4x plus 6x is 10x, and then negative 5y plus 8y is 3y. And then number 4, I kind of threw you a curveball. There are no like terms on number 4. So rather than leaving the problem blank, because it makes it look like you skipped it, either just rewrite the answer or say cannot be simplified. So I'll just rewrite the answer. I feel like that's easier. In the next section for the product rule, when multiplying like bases, you're going to add the exponents. So on number 5, your base is 3. So since those match, you're going to add your exponents. So 4 plus 2 is 6. And then typically we don't want to leave it like that. Typically we'd want to simplify. So you would just type 3 to the 6th power into a calculator and get 729. Pause the video and try 6. So now that you've tried 6, the big thing that people always mess up on this one, that last x is x raised to the invisible 1. So if you don't see an exponent, there's an invisible 1 there. So I'm going to add 5 plus 3, which is 8, and then 8 plus 1, which is 9. So that is it for that one. On number 7, we're multiplying those two terms together. Coefficients, the numbers in front, get multiplied like normal. So 3 times 4 is 12. And then the x's match. So 2 plus 5 is 7. On number 8, I don't see any like bases. So I'm just going to rewrite that same answer because you can't do anything to that. You can't simplify it further. In the next section, the quotient rule is for when we're dividing like bases. When that happens, you want to subtract the exponents. So on 9, a to the 5th divided by a to the 3rd, you just subtract 5 minus 3 and get a squared. On 10, the coefficients, the numbers in front, you want to divide or reduce those. So 6 and 8 are both divisible by 2. So I'm going to do 6 divided by 2 in the numerator to get 3. And then 8 divided by 2 in the denominator to get 4. And then with the x's, 12 minus 9 is 3. With 11, 3 and 6 are both divisible by 3. So I'm going to reduce this to 1, and 6 divided by 3 is 2. And then if I look at my variables, 1 is a y and 1 is an x, so those don't match. I typically don't like to have that 1 in the front in the numerator, so I'm going to rewrite this as y to the 33rd over 2x to the 12th. I wouldn't mark it wrong if you left the 1 in the front, but technically it's more simplified to not have the 1 there. On 12, 12 divided by 4 is 3. For the x's, 10 minus 6 is 4. For the y's, 9 minus 4 is 5. For 0 exponents, anything raised to the 0 power is going to be equal to 1. So this is a really fast section. 2 to the 0 is just 1. X to the 0 is just 1. On 15, since everything in the parentheses, it's all in the same set of parentheses, it's all raised to the 0 power, that's also just 1. And then on 16, coefficients, the numbers in front, get multiplied together like normal. So 2 times 5 is 10. And then for the x's, 5 plus 2 is 7. And then for the y's, 3 plus negative 3 is 0. So that part in the back, that y to the 0, this part right here, this is just 1. Let me make that a little less crazy looking. So that's just 1. So since that is a 1, we want to simplify that to just 10x to the 7th. Because 10x to the 7th times 1 is 10x to the 7th. For the power rule, when you raise a power to a power, you multiply the exponents. So on 17, since it's 4 to the 3rd power raised to the 2nd power, you do 3 times 2, which is going to be 6. And then, again, we don't usually leave it 4 to the 6th. We usually type that into a calculator and simplify it down to whatever it is. So that's 4,096. On 18, 6 times 5 is 30. On 19, very tricky here. If you don't see an exponent on a number, there's technically an invisible 1 there. So this negative 2 has a 1 as its exponent. The 3 on the outside needs to be multiplied by all the exponents inside. So this is really negative 2 in parentheses raised up to the 3 times 1 power. And then for the a's, 3 times 5 is 15. So that negative 2 in the front is being raised to the 3rd power. So negative 2 times negative 2 times negative 2 is negative 8. And then a to the 15 drags down. On 20, again, if you don't see an exponent, there's an invisible 1 there. So the 4 has an invisible 1, and the c has an invisible 1. So that 2 on the outside gets multiplied to all the exponents on the inside, even the invisible 1s. So you have 4 to the 1 times 2, a to the 3 times 2, which is 6, b to the 5 times 2, which is 10, and c to the 1 times 2, which is 2. And then don't leave that 4 squared a 4 squared, make it a 16 to simplify more. And then everything else just stays the same. There are no like bases, so you just leave it alone. With negative exponents, you're going to take the reciprocal of the piece with a negative exponent and make the exponent positive. So on 21, you flip it over, but instead of saying 3 to the negative 2, you make it 3 to the positive 2. And then obviously simplify. 3 squared is 9. With 22, flip it over, but instead of making it a positive, or sorry, instead of making it a negative 6, make it a positive 6, just like that. Now in 23, be careful. Only flip the part that has a negative exponent. So leave the 4 up top, leave the y to the 8th up top, but then the x to the negative 2, you're going to flip down to the bottom and make it a positive 2. On 24, the 5 does not have a negative exponent, so leave it alone. The x does have a negative exponent, so flip it down to the bottom and make a positive. The y has a negative exponent, flip it up to the top and make it positive, like that. 25 has a lot of different options. You can flip all your negatives first and then use the quotient rule and the product rule as necessary. Or you can start by just using the quotient rule and then do any flips as necessary. I'll actually show you both ways. So the first way I'm going to do it is I'm going to use the quotient rule first and then flip. So the quotient rule is the one that says when dividing like bases, subtract the exponents. So for the x's, 2 minus 5 is negative 3. And then for the y's, negative 3 minus negative 4 would be y to the positive 1. And I usually don't write the invisible 1. Then, since I have a negative exponent, I'd want to leave my y alone, and I'd want to flip the x to negative 3 down to the bottom and make it x to the positive 3. The other option with this problem is to flip the negatives first. So the y's, I'd want to flip those. So x squared and x to the 5th I'd leave alone because those don't have negative exponents. And then I'd bring the y to the negative 4 up to the top and make a positive. And then I'd bring the y to the negative 3 down to the bottom and make that positive. Then I would do my quotient rule. So with the x's, 2 minus 5 is negative 3. With the y's, 4 minus 3 is positive 1. And then I still have to flip that x to the negative 3rd down to the bottom like that. So either way you do it, you get the same answer.